Good morning everyone. I'm going to present feature fusion techniques in multimodal system. Fusion techniques overview. Fusion techniques generally refer to methods for combining information from multiple sources so that the final result is more accurate, complete, or robust than using a single source alone. These are the fusion techniques types. Data level fusion, it's also called as early fusion. Feature level fusion, it's called as mid level fusion. Decision level fusion, it's called as late fusion. And hybrid fusion. In the hybrid fusion, we can combine any of the two techniques. These are the fusion techniques types. So data level fusion, we are combining the raw data from multiple sources before any processing or feature extraction. So feature level fusion, we are extracting the features from each modality first, then it will be combined into joint representation. So for that we will be using feature concatenation, dimensionality reduction techniques and attention mechanism. The next one is decision level fusion. So here all the decision will be combined or output from the multiple model will be combined instead of raw data or features. The technique used here is majority voting, weighted averaging of probabilities, Dempster-Shafer theory. And in the hybrid fusion, so it combines the two or more fusion levels. So example, feature level and decision level. Advanced techniques YOLO level. So here mainly we will be using for YOLO level for object detection. So here you can combine the different data like numeric and textual data and image data, and that will be combined and given to the input to the YOLO model. So it will have the three components majorly: backbone, neck and head. So this is the entire architecture of the YOLO 11. So it will mainly have the backbone, neck, head. In the backbone, so it will have the convolution layers, C3K2 layers, SPPF layers, C2PSA layers. So these all layers will together extract the features. So that's what it's called as backbone. So main part of the YOLO 11 is it will extract the features. And then in the neck part, so what here main operations are concatenating the different inputs from the backbone and upsampling. So main operation happening here is concatenation and upsampling of data, and the head is for predicting the data. So the YOLO will detect the object or anything, so it will classify it, or segmentation purpose we can use it. So and then the data will be produced in the by the head part. So here convolution layer apply the multiple filters to learn different features. What is the use of the C3K2? C3 refers to the cross-stage partial with 3 convolution. So it provides efficient feature extraction and enhanced feature representation. And next one is spatial pyramid pooling first. A pooling-based module that captures multi-scale context information. It helps to detect the object of different sizes by fusing the features from the multiple scales, and which improves the small and large object detection in YOLO 11. And C2PSA module. What is the use of C2PSA module? PSA stands for polarized self attention. So which applies spatial and channel based attention to emphasize most important features and suppress the irrelevant ones. It enhances the feature representation by integrating the attention with convolutional blocks. So our next major operation performed in that backbone part is upsampling, which is the process of enlarging low resolution feature map to higher resolution. So next we can combine the YOLO model along with the multi-hit attention to improve the performance of the detection. So MHA model the large range dependencies and global relationship across feature maps by employing multi-hit attention mechanism. First, we'll have the three components query, key, and values, which are computed as given below. QU equal to Z into WQ. Z is the input matrix. From the it may be coming from the YOLO11, and the key equal to Z into WK, and VA equal to Z into WB. So the WQ, K, and V are the weight matrices. In the scale dot product attention approach, the dot product between queries and keys are normalized by the root of dk. A equal to QU KE of transpose to KE values. So A dash equal to A divided by root of dk. AW equal to sum of A dash. So A is the attention matrix, A dash is the scaled attention score matrix, AW is the attention weights. Then again we are calculating the attention weight based on the attention of QU, KE and VA. So equal to AW into VA. Based on this formula we can calculate it. And then we need to calculate the attention weight for all the hits. And then finally we need to combine all the hits to generate the final outcome. So this is the overall architecture of the multi-hit attention. So first we are receiving the output from the backbone, then those values are combined, and then scale dot product attention is applied, then we are concatenating all the input. So here suppose if you use some kind of numeric data along with the YOLO11 data, initially what we can do is, so image data can be fed as input to the YOLO11 model, and numeric data can be fed as input to the multi-layer perceptron model. Then we can fuse the outcome from the multi-layer perceptron as well as YOLO11 to generate the efficient outcome. So multi-layer, what is multi-layer perceptron? So here, as the name indicates, we will have the multiple layer. Obviously, minimum will have the input layer, hidden layer and output layer. What is the task of input layer? Which receives the input from the data set, and hidden layer, the task of hidden layer is which gets the input from the input layer and process it and generates the output, and then the output is fed to the output layer. So this is how the multi-layer perceptron is working. So here the main operation in multi-layer perceptron is forward propagation, backward propagation. In the forward propagation, the data flows from the input layer to the output layer, passing through any hidden layers. So in the backward propagation, the error is propagated back through the network layer by layer. So this is the way the multi-layer perceptron is working. Thank you.